Humans were always curious about the world around them. Various bright and heavy celestial objects in the night sky have always been fascinated humans since ancient times. Regular repetition of day and night, annual cycle of seasons, eclipses, tides, rainbows, and many other phenomena have always been a source of wonder for humans. The inquisitive and imaginative human mind has always responded to all these wonders and tries to find different ways to understand and express them. Humans always pay very keen attention to know the world around them, which results in the origin of science. Actually, the word science comes from the Latin verb scientia, which means to know. In Sanskrit, the word vijnana, and also in Arabic, the word ilm, convey a similar meaning, which is knowledge. Science has many branches, physics is one of them. If you want to know what physics is, then this video is for you. Here, I am going to share with you some important topics related to physics, such as what is physics, what is scientific method, unification and reduction, hypothesis in physics, the importance of mathematics in physics, branches of physics, some physicists, their contributions, discoveries, and inventions. So let's start. What is physics? If you want to briefly describe physics, it can be described as follows. Physics is the study of the fundamental laws of nature, and their manifestation in different natural phenomena. The word physics comes from the Greek word, physis, which means, nature. So it deals with the study of nature, in its full depth and dimensions. Physics is divided into two sections for convenience. Classical physics and modern physics. Classical physics began before 19th century. Many scientists in the age of classical physics have contributed to its development, like Nicolaus Copernicus, Galileo Galilei, Isaac Newton, and many others. Classical physics includes the study of mechanics, gravitation, sound, heat, light, electricity, and magnetism. Classical physics concerns such conditions where the speeds are much lower than the speed of light, sizes are much greater than the size of atoms, and relatively very low energies. According to classical physics, there are two entities of nature: matter and energy. So it starts with the study of matter, energy, and their motions. Modern physics began after 19th century. Many scientists, like Albert Einstein, Max Planck, Maurice Curie, Werner Heisenberg, and many others, contributed to its development. Modern physics includes the study of quantum mechanics, relativity such as special relativity and general relativity, atoms, molecules, nucleus, elementary particles, and condensed matter. Modern physics is concerned with extreme conditions, such as high velocities, which are comparable to the speed of light, small distances, which is comparable to the atomic radius, and very high energies. What is scientific method? The study of science, particularly in physics, is based on systematic observations, controlled experiments, qualitative and quantitative reasoning, mathematical modeling, prediction, and verification, or falsification of theories. All these steps taken together constitute what we call the scientific method. It helps us to describe various physical phenomena, which gives us scientific theories. But the scientific theory must be verified by relevant observations or experiments. Unification and reduction. Unification. In physics, it is a method of combining different laws, valid for different phenomena, to form a single theory that explains all those different phenomena. For example, electricity, magnetism, and light are different phenomena, and have different laws of physics for each of them. Here the theory of electromagnetism is the unified theory for all of them, which describes all these phenomena in a single theory. Reduction. In physics, it is an attempt to solve various complex problems by breaking them down into simple parts. For example, the temperature of a system is reduced to average kinetic energy. Hypothesis in physics. If you are thinking, everything can be proven with physics and mathematics, then that is not the case. Because all physics, and also mathematics, are based on assumptions. All these assumptions are known as hypotheses. For example, Newton's universal law of gravitation is a hypothesis, and Einstein's special theory of relativity is also a hypothesis. Even before Newton's proposed hypothesis, there were multiple observations, experiments, and data on the motion of the planets around the Sun, the motion of the Moon around the Earth, bodies falling toward the Earth, and so on. Each of these required a separate explanation, which was more or less qualitative. But, with the help of Newton's universal law of gravitation, we can easily explain all these phenomena in one stroke. Similarly, it goes for Einstein's relativity. So, the hypothesis is a proposed solution for an unexplained phenomenon that does not fit the currently accepted scientific theory. The fundamental idea of a hypothesis is that there is no predetermined outcome. For a hypothesis to be a scientific hypothesis, the scientific method requires that anyone can test it. Which means, it can be verified and substantiated by experiments and observations. Mathematics in physics. All these phenomena of nature can be easily explained if we have the freedom to use mathematics to explain them. That is why physics is directly associated with mathematics. In physics, we use various mathematical techniques, like algebra, trigonometry, and calculus, to explain those phenomena of nature. So, without the knowledge of mathematics, it would be very difficult to discover, understand, and explain the laws of nature. That is why mathematics plays a very important role in physics. Branches of physics. The scope of physics is gradually increasing as humans try to understand the laws of nature more deeply. Now you can see, the scope of physics is truly vast. In this video, you will see a brief discussion of some branches of physics that may give you some idea of the scope of physics today. Astronomy. The branch of physics that involves the study of space. Acoustics. It involves the study of sound and sound waves. Atomic physics. Atomic physics involves the study of atoms, specifically the electron properties of the atom. Biophysics. The branch of physics that involves the study of living or biological systems. Cosmology. It involves the study of the universe as a whole, including its origins and evolution. Crystallography. It involves the study of crystals and crystalline structures. Electromagnetism. It involves the study of electrical and magnetic fields, which are two aspects of the same phenomenon. Electronics. The branch of physics that involves the study of the flow of electrons, generally in a circuit. Fluid mechanics. It involves the study of the physical properties of fluids like liquids and gases. Geophysics. The branch of physics that involves the study of the physical properties of the Earth. High-energy physics. Study of extremely high-energy systems, generally within particle physics. High-pressure physics. Study of extremely high-pressure systems, generally related to fluid dynamics. Laser physics. The branch of physics that involves the study of the physical properties of lasers. Mathematical physics. The branch of physics that involves the study of mathematical methods, which are applied to solving problems related to physics. Mechanics. It involves the study of the motion of bodies, in a frame of reference. Meteorology, or weather physics. The branch of physics that involves the study of weather around us. Molecular physics. The branch of physics that involves the study of the physical properties of molecules. Nuclear physics. Nuclear physics involves the study of the physical properties of the atomic nucleus. Optics, or light physics. The branch of physics that involves the study of the physical properties of light. Particle physics. It involves the study of fundamental particles, and the forces of their interaction. Plasma physics. The branch of physics that involves the study of matter in the plasma phase of matter. Quantum mechanics, or quantum physics. Quantum mechanics involves the study of science where the smallest discrete values, or quanta, of matter and energy, become relevant. Many models and theories like quantum field theory, quantum gravity, and string theory are involved in it. Relativity. Einstein's theory of relativity generally involves moving at speeds very close to the speed of light. We will deeply touch on the topic of special relativity and general relativity in the upcoming videos. Statistical mechanics. It involves the study of large systems by statistically expanding the knowledge of smaller systems. Thermodynamics. The branch of physics that involves the study of heat. Some physicists and their contributions. There are many brilliant physicists, mathematicians, and scientists who have contributed to the development of physics. In this video, we have tried to briefly discuss some of them. Archimedes. Archimedes was a Greek mathematician, of time 287 to 212 BCE. He is famous for his ideas regarding fluid mechanics and the development of the law of buoyancy, which is also known as Archimedes' principle. Nicolaus Copernicus. Nicolaus Copernicus was a Polish astronomer, of time 1473 to 1543. He is famous for his development of a heliocentric model of the solar system. Galileo Galilei. Galileo Galilei was an Italian mathematician, astronomer, and physicist, of time 1564 to 1642. He is famous for his astronomical discoveries, empirical experiments, laws of inertia, and his improvement of the telescope. Isaac Newton. Isaac Newton was a British mathematician and physicist, of time 1642 to 1727. He is famous for his universal law of gravitation, laws of motion, and for building the first functioning reflecting telescope. Michael Faraday. Michael Faraday was a British scientist, of time 1791 to 1867. He contributed to the study of electromagnetism and electrochemistry. He is famous for his laws of electromagnetic induction. James Clerk Maxwell. James Clerk Maxwell was a British scientist in the field of mathematical physics, of time 1831 to 1879. His achievement was to formulate the classical theory of electromagnetic radiation, where we learn light is an electromagnetic wave. For the first time, he brought together electricity, magnetism, and light and said that these are different manifestations of the same phenomenon. For this, he develops equations which are known as Maxwell's equations. Heinrich Rudolph Hertz. Heinrich Rudolph Hertz was a German physicist, of time 1857 to 1894. He first proved the existence of electromagnetic waves predicted by James Clerk Maxwell's electromagnetic equations. J.C. Bose. Jagadish Chandra Bose was an Indian biologist, physicist, and botanist, of time 1858 to 1937. He led the investigation of radio and microwave optics and made significant contributions to botany. W.C. Ranchon. Wilhelm Conrad Ranchon was a German mechanical engineer and physicist, of time 1845 to 1923. He was famous for detecting electromagnetic radiation in a wavelength range known as X-rays or Roentgen rays. J. Thompson. Joseph John Thomson was a British physicist, of time 1856 to 1940. He is famous for the discovery of the first subatomic particle called electrons. Marie Sklodowska-Curie. Marie Sklodowska-Curie was a female French physicist, of time 1867 to 1934. She was conducted pioneering research on natural radioactivity. She is famous for the discovery of radium and polonium. Albert Einstein. Albert Einstein was a German theoretical physicist, of time 1879 to 1955. He is famous for developing the theory of relativity, like special relativity, and general relativity, photoelectric effect, and theory of Brownian motion. Victor Francis Hess. Victor Francis Hess was an Austrian-American physicist, of time 1883 to 1964. He is famous for discovering cosmic rays. R. A. Milliken. Robert Andrews Milliken was an American experimental physicist, of time 1868 to 1953. He is known for oil drop experiments, measuring the charge of the electron, and working on the photoelectric effect, and cosmic ray physics. Ernest Rutherford. Ernest Rutherford was a New Zealand physicist, of time 1871 to 1937. He gave the nuclear model of the atom, and also famous for the discovery of protons, the discovery of alpha and beta radioactivity. Niels Bohr. Niels Bohr was a Danish physicist and also a philosopher and promoter of scientific research, of time 1885 to 1962. He has major contributions to understanding atomic structure and quantum theory. He is famous for his atomic model known as Bohr atomic model. C. V. Raman. Chandrashaker Venkata Raman was an Indian physicist, of time 1888 to 1970. He was working on the scattering of light. He is famous for the discovery of a new type of scattering of light, which is subsequently termed the Raman effect. Louis Victor de Broglie. Louis Victor de Broglie was a French physicist and aristocrat, of time 1892 to 1987. He made groundbreaking contributions to quantum theory. He postulated the wave nature of electrons and suggested that all matter has wave properties, which is known as the Broglie hypothesis. M. N. Saha. Meghnad Saha was an Indian astrophysicist, of time 1893 to 1956. He is famous for developing the Saha ionization equation, which is used to describe the physical and chemical conditions in stars. S. N. Bose. Satyendra Nath Bose was an Indian mathematician and theoretical physicist, of time 1894 to 1974. He plays a major contribution to his work on quantum mechanics. He collaborated with Albert Einstein in developing the foundation for quantum statistics or Bose-Einstein statistics and the theory of the Bose-Einstein condensate. Wolfgang Ernst Pauli. Wolfgang Ernst Pauli was an Austrian theoretical physicist, of time 1900 to 1958. He is famous for his discovery of a new law of nature, known as the exclusion principle or Pauli principle. This discovery involved spin theory, which is the basis of the theory of the structure of matter. Enrico Fermi. Enrico Fermi was an Italian physicist, of time 1901 to 1954. He made very significant contributions to the development of statistical mechanics, quantum theory, and nuclear and particle physics. He is known for demonstrating the first self-sustaining nuclear chain reactions. Werner Heisenberg. Werner Karl Heisenberg was a German theoretical physicist, of time 1901 to 1976. He made very significant contributions to quantum mechanics. He is famous for his uncertainty principle. Paul Dirac. Paul Adrien Maurice Durack was a British theoretical physicist, of time 1902 to 1984. He made very significant contributions to the development of both quantum mechanics and quantum electrodynamics. He is famous for formulating the Dirac equation which describes the behavior of fermions and predicted the existence of antimatter. Erwin Schrdinger. Erwin Rudolph Joseph Alexander Schrödinger was an Austrian-Irish physicist, of time 1902 to 1984. He made very significant contributions to the development of quantum theory. He is famous for providing a way to calculate the wave function of a system known as the Schrödinger equation. Edwin Hubble. Edwin Powell Hubble was an American astronomer, of time 1889 to 1953. His name is most widely recognized for the Hubble Space Telescope, which is a major contribution to astrophysics. His famous law to understand the universe is expanding known as Hubble's law. Ernest Orlando Lawrence. Ernest Orlando Lawrence was an American nuclear scientist, of time 1901 to 1958. He is known for the invention of the cyclotron. James Chadwick. James Chadwick was a British physicist, of time 1891 to 1974. He is famous for discovering the neutron. S. Chandrashaker. Subramanian Chandrashaker was an Indian-American astrophysicist, of time 1910 to 1995. He was awarded for theoretical studies of the structure and evolution of stars and black holes. The Chandrashaker limit is named after him. If you enjoy our videos, then don't forget to like, share, and subscribe.